So we'll give a name of this. So if this screen is familiar to you, that means you have used Colab Notebook. Okay. So let's say predicting MTBF for CT scanner. Okay. Okay. So now just like in case of 9, we had to upload a file and read the file. Here also you have to upload a file, and the place to upload it locally is if you go to the files over here, and you see a folder called sample data. Just see if you are getting this folder, you should be able to get it. If you are not, then go to a level up, right click and create a new folder. Okay. Just check if you are able to get this folder. These are default folder that is usually there. Okay, for uploading. You can create a new folder also to put your data, but for now, this is good enough. And this is usually non-persistent storage. That means once once you have uh, completed your work and close the notebook, this data set will no longer be there unless you specifically ask the data set to be there. So under the sample data, you see these 3 dots are there, and here you just upload the file. Okay. So you will see this data over here. And you can see everywhere you have this, this symbol. Wherever you have this symbol, that means this is assisted by Gemini. Okay, you can use Gemini for assisting. Okay. So everybody has uploaded this data. Yes.
I was able to do it, sir.
Okay,
Thank you.
great. Okay. So now today generative AI is so powerful that even if I don't say anything, okay, just say this is the data set and I want to predict mean time between failure, it would be able to do it reasonably accurately, even without telling any of the steps. Okay. However, we always say that there is a question of human in the loop. Human in the loop means that I must understand what generative AI is doing, though I need not do it myself. Okay. So it's a difference between saying, let's say, when you are a manager and your employee is actually doing the work, you must know what your employee is doing to figure out if an employee is doing something wrong, though you yourself are not doing the job. So it's the same thing. I need not do all the steps myself, but I must know all the steps, because if generative AI is hallucinating or giving a wrong output, I should be able to find that. So it should be used as a productivity tool, not as a tool to replace my intelligence. Okay. It's probably, that is too risky as of now to say that my entire work without any human in the loop will be replaced by generative AI, and I can fully trust generative AI that it will come up with right solution. So I need the human in the loop to be accountable for any errors as well as correct any errors. So same thing here. I may tell generative AI to do everything, but still I should know the steps that are required to do this job. Okay. Only thing I do not need to know is the exact syntax of the code. That is something that I'm asking GenAI to automate. Okay, that's why the role of coders will largely get eliminated, especially the lower end coders in any IT department, IT company as well as in IT department. 60-70% of the coders are the low end junior coders. So their jobs will not be required anymore. Okay. So that's where the hit is going to come. But otherwise, I need to know what are the steps. So, first I need to read the file. Okay. So I will just copy, first of all, the path of this file, and then I can write the code. If I know Python, I can write the code how to read this file. But the good thing is that I don't now need to know the syntax. All that I'll do is I'll go here and say that read the file. So Python is also, remember, Python is also an intermediate translating language, or any code for that matter is not the real language in which the machine understands. The machine only understands ones and zeros. Python or R or any of these languages are also intermediate languages. Now that language has gone to one level higher up, and it has become like natural language. So just I have to write in natural language. And by the way, you can even write in Hindi or Tamil or Bengali, okay, and it will understand equally well in most of the cases. Read the file and show the head of the data. That's all I need to write. And it will generate the code for me. So it has generated the code. It has written the code also here. You can see, those of you understand Python, no, it's a very simple code. PD is a library called pandas. It's because whenever you're using any of these coding languages like Python or R, you already have pre-coded files equivalent to the specific nodes that you used in 9, where things were already pre-coded and you just dragged and dropped and configured some of the values. Same way in Python and R, there are packages or libraries. Okay. These libraries are pre-coded pieces of softwares, and you don't write every time when you write a code. You don't write the code from bottom up. You essentially call these libraries. PD, for example, is the library called pandas. Okay. And saying that PD read underscore CSV. So this is asking to read the CSV, and it is giving the folder from where to read it, and then display this, store this in DF. What is DF? DF is nothing but data frame. Data frame is a temporary table where the data will be stored to be used. And then it's saying that display the head of the data frame. As simple as that. Okay, 2 lines of code. Those who know Python will probably write it just like that. But good thing is that even if I don't know Python, I'm able to write it. Okay, so just say accept and run. Say accept and run. You see, it has run this nicely, and this is the data set. You've already seen. Okay. Correct. Tell me what is the next step. What is the next step we should do?
Filtering.
Filtering. Very good. So I can just write a code over here and say, or I can also write it from here. Okay. So I can also write it from here and say that filter out machine ID and store the data in a new data frame. show the head of the new data. You say df underscore filtered is the name of the new data frame it has created. Df dot drop, so just drop this machine ID, okay, and display the head of it. We have this. Okay, so next what we can do. Next, let us do some exploited analysis. Like last time, we did some exploited data analysis, but before doing exploited data, or rather, as a first step of the exploited data analysis, let us we didn't do this explicitly in 9. In 9, the statistics were already available when we read the file. So here it is not directly available. So we ask to provide a summary of the statistics of data frame df underscore filter. It is always better to give the name of the data frame, because otherwise it may get confused which one I am asking for. Now that there are two data frames, one is df and the other is df underscore filtered, it might get little confused which one I'm asking for. Okay, provide a summary of statistics of data frame df underscore filter. So you see that describe is the function, very simple function, and it has given me how many count, total number of instances, what is the mean value for each of this, what is the standard deviation, obviously only for those cases which are numeric, minimums 25 percentile, 50 percentile, 75 percentile, and maximum. Okay, so this is the values that is given for obviously numeric values. It is not going to give for categorical values. Okay. What is the next thing that we should do? What is the next thing?
To check the correlation between.
Okay. Now, before the correlation, we also wanted to find out what is the, if there are any outliers, remember?
Outliers, yes.
Yes. Okay. So let's ask for this outliers. Let's ask for box plot. So I can give the names of all the variables. Otherwise, I can just say it should work. Create box plot, or create box plots for all the numeric variables in the data frame df underscore filtered. Okay. So whenever it is, whenever you ask it to do some longer, calculations, it will also tell you the steps. Okay, identify the numeric count, create box plot, display box, or summarize the findings. Okay, so it's asking you that is this the set of steps that you want to do, and you can say accept. It is doing all of these steps one by one. If it faces an error, always remember that there is all, let's see, if such situation arises, it will there is an option to explain error. Okay, and once you get an error, it will itself figure out how to fix the errors. Okay, so you see all of these things. It has also documented it. It has imported this library called matplotlib, which is, so this is the all the box plots. Age of machine years, days since last service, ambient temperature, we have some outliers. Okay, machine temperature, vibration level, some outliers are there, radiation leakage, some outliers there, voltage fluctuations, some outliers are there, pressure, some outliers are there, MTPF hours, one outlier is there. Okay, so these are the columns on which they are there. The box plot provides visual representation. Then determine the validity and impact on data analysis. Okay, so if you want to do some more analysis on what is the impact of these outliers, etc., you can do that. Okay, fine.
Professor, in our
Everybody clear?
case,
Yes.
it has not explained these steps.
Okay, so see, any generative AI, remember, this is one of the disadvantages of generative AI. Any generative AI process is a stochastic process. It's a non-deterministic process because it works on, let's see if we have some very brief sessions on generative AI and large language model, how they work. Basically, it works on probabilistic output. So, given the same inputs, all of us may not receive the same output. Okay. So it's very much possible that something that I have got, you have not got, or vice versa. So only way to do that is, first of all, there are two types of things. One is what you mentioned, that something, some information which it has given to me, it has not given to you. That is an easy problem to solve. You just ask that summarize this information and give a report on that, your findings, it will do that. Okay. But sometimes the bigger problem is that if it hallucinates means that it gives the wrong information. For example, I mean, usually not with this kind of very straightforward questions, but if it's a more complex question, it may lead to a situation where actually there are no outliers, but it's showing there are outliers. Possible. Actually, there are no outliers in the data, but it's showing as outliers. Possible. Because it's non-deterministic. Okay. It is finding out probabilistically what is the outcome. And that is why you require human in the loop. That is why in certain cases you have to check, okay, especially the exceptions. Okay, if 3 observations are outliers, are there really 3 observations which are outliers? That is what, as a human, you have to check. Okay, but usually what happens is that because the code, if the code has been written correctly, because you can, this is where you may want to understand what the code is. So if the code has been written correctly, then you don't need to worry about it, because if the code is correct, that means the output also should be correct, because the same thing as writing the code manually. Okay, but yes, there will be certain human guardrails required. But again, as I say, what is your purpose? You as a business user, you have to, your job is to first identify use cases in your organization, in your workplace, where you will apply analytics. That is your job. Okay, digital team cannot tell you what will be the use case. You have to identify the use case. Now, usually, I'm not sure whether you are doing it or not, but suppose you are doing that, then now, right now, you are just doing it and passing it to the digital team to do everything else. That should not happen. Okay, you will do the prototype. You will figure out whether this is a valid use case or not, whether from a business perspective it makes sense for you, from a cost benefit perspective it makes sense for you. Once you have done those prototyping and you need to implement it, that is when you will hand it over to your digital team. And that is why you need to do these activities. So, and because the prototype, even if it goes wrong a little bit, doesn't matter. Clear? So far, fine, everybody?
Yes, yes.
Great. Okay. Now, if you remember that I said that in case of 9, we did not remove the outliers. Okay. Always remember that the best treatment of any outlier is to remove it. Okay. Because whatever value you may want to replace it with, that will not be the real value. So best treatment for any outlier is to remove this outlier so that it doesn't affect your overall result. I also mentioned that this is not true for all types of problem, especially those type of problem where one of the classes which you are trying to predict is a very rare class, like a fraud detection. Number of cases of fraud will be a very, very small percentage of the actual number of banking transactions, not fraudulent or genuine banking transactions that are happening. Okay. So in such a situation, if you remove the outliers, all the fraudulent cases will get removed, okay, which will not be a right strategy. But things like situations like this, when you're trying to predict the mean time between failure, it is okay to remove the outliers. But in 9, that is slightly difficult. You have to use a lot of nodes and do this. But here, let's see whether it is difficult or easy. So what I'm going to write as a prompt is that remove the outliers from the data frame df underscore filtered okay, and store the new data set in a new data frame. Show the head of the new data frame. So I wanted to remove all the outliers that has been identified. Okay. Remove the records containing the outlier. Okay. Because it's not that I'm removing the outlier, I'm removing the entire record. So any value, if any of the values is an outlier, the entire record should be removed. And we have already seen that even if we remove some of these, outliers, we should be left with enough number of records to do our activities, because we have 1,000 records and probably the number of outliers should not be more than 15 or 20. Okay. Visually, that's what it appearing to be. So it is saying what all it is going to do. So again, this is where the human in the loop comes in. Human in the loop will check that whether the process that it is adopting is right or wrong, and then accept.
Sir, Saurabh
Yes.
here.
Yes.
Sir, my system got restarted. So can you just tell the 2 steps which happened before? I just need to get
Yeah,
again, sir.
sure. Okay, so the first step, we read the data. Okay, we said that read the data from we uploaded the data in the first place in sample data. Then we read the data, and after we read the data, we asked for a summary. Okay, give a summary of the data. Then we said that you create box plot for all the numeric values. And before that, we also dropped the machine ID, okay, because of high card rate. So these are the 3-4 steps that we did.
Okay, sir.
Okay. Let's see, it is done. Okay. So it is the new data frame DF, no outliers. So this is the data frame. Now, just to ensure that we have actually got our outliers out, what we'll do is we will first say give a summary statistics of DF no outliers. Because we want to know how many records were removed. So here you see 965. So that means 35 records have been removed as outliers. Okay. It also asks to create a box plot. Create box plots for all numeric values. Okay. So now we should not have any outliers. The ambient temperature, you can see here still there is one outlier, but as I mentioned that this one outlier can be either hallucination before or after. Okay. Ideally, after I have removed all the outliers, there should not be any outliers, but still there is one outlier which might be because either in the beginning itself it did not figure that out that this is the outlier, or after removal or the removal process did not remove this particular outlier, or after removal it is considering something else to be an outlier. So that this is the kind of sometimes you see the hallucination. Okay. So far fine, everybody? Yes or no? All good?
Yes, yes.
Great. Okay. So let us now do the correlation matrix. Uh, uh, do a correlation matrix for all numeric values in the data frame, except because I don't want this value. What is the MTBF hours. Okay. So now this is additionally, remember here, there we got a number, but we did not get a kind of a heat map. Show the correlation matrix in the form of a heat map with negative value in the red scale and positive value in the blue scale. That means if the correlation value is towards negative, -1 will be very deep red and +1 will be very deep blue. And in between, this will be difference. So saying all of these things, okay, they accept an auto run. Let's see. Let's see. A very nice heat map, but it has understood it little wrongly. Okay. It has understood one as red and okay. So this, you see, this is where sometimes it didn't understand what I said. Okay. And that's where probably you could have made it more clear saying that +1, I could have made it more clear saying that +1 should be blue and -1 should be red, like that. Okay. Otherwise, what else done? It has put one as red and everything else in shades of blue. Okay, but we have got the correlation matrix. Now, ideally, we can do this principal component analysis and all those kind of things, but for the time being, I will leave that. Okay. What is the next step that we want to do? What is the next step we want to do?
You have to handle the categorical variables.
Yes, and we have to do one hot encoding. Do one hot encoding of all the categorical values. Remove the original or filter out the original categorical value after one hot encoding. Original after one hot encoding and store the new set of data, both all numeric now. In a new data frame. Show the head of the data frame. Yeah. Perform or not encoding, store resulting data frame, use a variable, results suggest next steps. Okay, let's see. Only thing I'm not very sure is that it should not take off the original numeric value. So let's see. So what we are doing normally, it would have taken probably at least 3-4 hours for even a relatively good programmer to write. So that's the efficiency of this kind of platforms. How big is the IT team in Bosch and where do this normally sit? Any idea?
The IT team, in the sense, we have a separate software center,
Okay.
which is called Bosch Global Software Solution Team. So,
Okay.
So that is a big unit. We have more than, I think, 8,000 to 10,000 people there.
Okay. So all your IT work is done by them?
No.
How is it?
We have an internal, for manufacturing, we have internal teams.
Okay.
Specific to the plant or the production. Yeah.
Okay. Okay. So there are certain IT jobs which are decentralized, which is done within the manufacturing units, and there are certain jobs which are centralized, right?
Yes.
Which is done by this Bosch.
We take their service for any.
You take the service. Okay. So can you give an example of a service that you take from them and something that you do internally? Just for my understanding. By the way, the results are out. I mean, it has come. So I'm just, while you're answering, I'm just checking whether it has given the right. You can also check given the right result or not.
Example would be the platforms. For example, they have created a platform AOI Studio, which is a automatic inspection, optical inspection studio, which has a module. We can use it for image processing and then finding defects.
Okay. It's a computer vision. It's a product developed for computer vision, right?
It's mainly the camera which captures the images and then it can be uploaded into that platform.
Yeah, and it
will help.
Yeah, and the platform will identify whether there's a defect or not.
Yes.
Okay. Yeah. So it's a product that basically does computer vision and yeah.
Yes.
So is it a batch process or just for my, is it a batch process or is it also, for example, if it's a defect, it will send back a signal to stop the line, for example.
Yes.
It does that. Okay.
It's a dynamic.
Very good. Very good.
integrated. Yes.
Okay, very good. So that's the kind of industry 4.0 applications that definitely companies go for. So those kind of things are done by the central team. Obviously, it makes sense because those are pretty high end things. And what about an example of
So our
something
internal
that
team will adapt that AOA Studio and then implement this in our lines.
Okay. So they are doing they're taking the product and implementing.
Yes.
But who does this kind of analytics work? And where is it being done? Let's say I'm sure this kind of predicting machine failures and those kind of things are being done. But is there anybody in the organization who in there? Not anybody. Which entity is doing that work?
So we have a specialists, data scientists and data analysts qualified.
Okay.
They are there in the individual production team.
Okay.
Qualified. They will assist like as a interface between the users and the IT team.
Okay. Got it. Okay. So coming back to this, you can see here that I asked it to do few things. One is I asked it to do one-hot encoding, which it had done correctly. Also, I asked to remove the original categorical values. Okay, so you see here the error code that is no longer there because that was very important because otherwise that had to be filtered out. Okay. Also, you'll see that usage mode, okay, high load, usage mode, idle, all of these things are there, and the original values have been filtered out, and also the numeric values have been kept as is. Okay, so it was a little complicated prompt which has been successfully executed by these guys by Gemini. So good. So I think this is fine, and this new data set is DF_encoded. And we are going to use this data set for our regression. So the next step, anybody remembers the next step?
The training and testing.
Now, before that, we have to normalize the data.
Normalize,
right?
yes, correct. Yes. Scaling.
Yes, scaling, right. So normalize all the data in the name of the thing is DF_encoded. Okay. Encoded except we don't want to normalize this data. MTBF hours.
Encoded.head we have to write.
No. Encoded, the data frame is encoded. DF_encoded. Head means that head is it is a command which says that display the head of this DF_encoded.
In your case, it is showing the steps here.
Hmm.
But when we are trying to run, it is only giving the like a prompt explanation. Like I can do this.
Okay, it is not telling you the steps.
No.
Might be
Only
a
this one
version
line
issue.
it is telling.
Okay, understand. Might be a version issue. I might be using a higher version of Gemini. Maybe. Okay, maybe that might be one of the reasons. Yeah, I'll check that once. To check it in your computer. Might be a version issue. Otherwise, there is no reason why you'll not get it. Okay, so So you see, it is saying that first is taking out MTBF hours because it doesn't want to normalize. The rest of it is normalizing and then adding MTBF hours. So some of the cases you see that is still showing working, but normally if the last step is done, you can just try it out. Usually it has completed the work. Okay. So you have this normalized data. Okay, you can see here it has not done a 0-1 normalization. Okay, it has done a Z normalization, which is minus 1 to plus 1. Okay. Because as I mentioned that it is not a good idea to do a 0-1 normalization. Where is the MTBF hours is there? Okay, great. Okay, so it has gone. So if I specifically said that do a 0-1 normalization, it would have done it. But I think it's fine.
In my
Yes.
case, the
Yeah.
negative values are not there. I think it has done
Okay,
only
so
0
for
to
you,
1
it has done a
by
0-1
default.
normalization.
So we have
So
to
just-
mention in the prompt telling that to
yeah.
normalize
So if
between
you
-1 to +1.
or based on Z-score normalization or 0-1 normalization. So if you do that, if you get specify that, then it will automatically do specifically that. If you don't mention that, it might do it differently, as we saw. It's non-deterministic. So in your case, it has done 0-1. My case, it has done a Z-score normalization.
Okay.
Okay. So I leave it here. I can't further ask it to do a 0-1, but then I'll leave it like that. Okay. It is called standard scalar. Okay. This is the normalization that they have. It's a more sophisticated normalization, so it's a good thing. Okay, so now we'll say consider MTBF hours as the target and all other features as input. Split the data frame df underscore normalize into training and test data set with 70% data in training and 30% data testing. Split the data using random sample. Okay, let's see. It has created. So normally what it does is always has two values, X, which is based on features. Y is the small y is the outcome. Okay, you can see here it is also giving you a distribution, and it has converted it into train and test. Okay. And this is the shape. So shape means that in the train there are 675 rows, 19 columns. In the X test, there's now 290 rows, 19 columns. In Y train, 675 rows, only one column. Okay, because it has only the MTBF hours value. And in Y test is 290 and only one column. That's how typically it will define. Okay. So I'll ask now, create a train a regression model on the training data set to predict MTBF hours and apply the model in the test on the test data set. So R square value for both training and test data set. Remember that we are more interested in the R square value of the test data set. The training data set, if it has a very high linear regression model, you should write multiple linear regression model. Okay. Because if we want to have, if we see a very high R square value in the training data set, it's likely that the R square value for the test data set will be low. So always remember our objective is to have a good R square value, not very high on the test data set.
So before this, have we given this partition like 80-20, 70-30?
Yeah, we
Do we
we
need to
did
do that?
that. We did we did it.
Ah,
We divided into 70-30 using random
okay,
sample.
okay,
Okay, so these were 675 is in the train and 290 is in the test.
perfect. Thanks.
I should have done it. Let's see. So here you see that training data has got 0.42 and the test data is 0.37. If you remember that this is also similar kind of R square value that we got in our 9 as well. Okay. So it's not a great model, but that's the best that this model could do. Okay. But we intended to create this entire model using Gemini, and the entire thing we created using prompt. As you can see that quite a bit of code has been written, but we did not have to write anything as far as coding is concerned. Okay.
If the
Fine.
R-square shows more than 0.8, then we can use this model for prediction. Correct? That is the conclusion.
If they ask for
R-square is more than 0.8,
yes,
then we can take this model.
So you
for
can,
prediction.
so then you can say that my prototype is now fine, and now I can give it to the digital team to once you do the prototype, what will the digital team actually do, right? The digital team has to, of course, make the model better in terms of fine-tuning the model, in terms of doing some more data pre-processing, in terms of doing some more feature engineering, like we said, that principal component analysis, those kind of things, and most importantly, the scale. So you might be building a prototype, especially for your industry. The volume of data is huge, and most of these data are live streaming data. Like you are talking about computer vision, right? So the data is not, it is a streaming data that is coming. Okay, it is not like a sales data or purchase data where somebody is entering, or it is a batch process. More like I'll not say batch process, it can be real time, it is a slow data. So every time, let's say in a retail store, a scanner is you have a scanner, and then in the point of sale system, a sale is recorded. That process is much slower compared to when you have a manufacturing line and you have a computer vision system which has to capture the picture image, and then the back end it has to process and identify that it is a defect, and then send back the signal back to the assembly line to stop the line. Now that has to have a very low latency. It's a very real-time thing. So this data now has to be incorporated into a data lake, a cloud-based data lake system. Okay, and there will be some cloud, some edge computing involved. And then once the model has been deployed, this model has to then also interact with the external environment to be able to give the signal back. So this entire thing, when the real implementation comes, the real implementation will be much more complex than what this proof of concept is. So the proof of concept is the business's verification that yes, this is a type of model that we want to build to benefit the business. And then the digital team takes over the implementation at scale. So that's the difference, or that's the difference in responsibilities that these two teams should play. Does it make sense?
Yes, sir. Thanks, sir.
Okay. So I mean, just being curious. So today, for example, when you said that you are taking some input from your central team, like a computer vision, or let's say there's a data scientist in your team who is helping to do something locally. Can you give an example of a typical input that you as business user give to the either the central Bosch digital team or the data scientist which working along with you? What kind of input you provide and what kind of work they are expected do?
Now, as a business user,
Mhm.
we actually propose the projects,
Okay.
the potential
Like,
problems, what we are facing,
like,
and
yeah, like even, can you
example
give an example of a project?
example will be, I will uh, give you an example where we have this capsule packaging.
Okay.
Mainly, we have aftermarket product. Is a
Mhm.
small, I would say, it is actually a delivery valve, which we pack into a small capsule, a plastic container
Okay.
of size maybe 2 inches
Okay.
and diameter of 1
Delivery,
inch.
delivery valve.
It's a delivery valve.
What
It
is it
goes
used for?
into it goes into the pump, fuel injection pumps.
Okay. Okay. Okay.
It is used as an aftermarket product. It gets
Okay.
sold.
Okay. Got it.
It goes
Got it.
into
Yes.
OEM, our product also, and
Okay.
aftermarket, but packaging this delivery valve into a small container where we
Okay.
have some accessories like washer,
Okay.
seal ring, and delivery valve
Okay.
packed together.
Okay.
So
Okay.
what will
Fine.
happen? This packaging happens in a automated way, but only
Mhm.
thing, the washers are manually.
Put it.
The machine will put the washers, and then this has to be manually inspected.
Okay.
While
Mhm.
we have a customer complaint telling that some washers are missing in some of the capsule packaging.
Okay. Mhm.
So this, as a customer complaint and also internal defect, we took this
Mhm.
project and gave this project to our team, telling that the
Okay.
capsule packaging washers are missing. So this has to be
Mhm.
detected by image processing.
Okay. Mhm. Okay.
And then for example, we have around 50 to 60 containers
Mhm.
stacked in one go,
Mhm. Okay.
and then
Okay.
the which container the washer is missing, it has to be predicted.
Right. So
uh,
that's where the computer vision has to figure
yes,
that out.
yeah.
Good. So this went to the central Bosch team, or it
No,
went to the.
actually, we have this AOI, so we adapted that platform. Our IT team
Uh,
suggested, and then we use
uh-huh.
that.
Okay, so you use that platform which the central team has built, and then maybe
Our
customize
IT
that
team,
for this
yes, yes.
particular problem, and then post it. Okay, got it. Got it. Okay, understand. Yeah, so some of these problems are kind of these are more your deep learning problem where the business input required is not very high. Okay, because as a business user, all that you need to say is that I need to identify that the washer is missing. That's it. Okay. So the business input required is not very high. And obviously the technical team's role is much bigger here because technical team has to figure out how to implement that. Okay.
So we have a data
But
analyst in our team. So they will do all the technical aspects, and they will involve along with our digital team within the plant. They'll
yeah,
take
no,
their
no, I got
support, and
it.
then
But
yeah.
yeah, but got it. But people like you as a business user, your input is not, except identifying the issue that yes, the washers are getting missed out, and we need to have a method by which on the line we should be able to figure out which washer has been missed out. Except that, and the fact that the computer vision can do this, except that you don't need much of
Yeah, yeah.
yeah
Much of inputs are not required.
much of inputs. Okay, these are typical case of a deep learning, especially image processing. However, challenges like where you're trying to predict the machine failure, when you're trying to, let's say, in a generative AI
I will
kind
give
of
you one more
environment.
example.
Yes, yes,
So we have this series of machines
yes.
which will give my final product.
Okay,
Okay, there is a series of machine have different processes, like some are grinding,
right,
some are deburring, cleaning.
right, right,
Some
right.
different processes are there. At the end,
Uh-huh.
I will finally test that part. So while
Yes.
testing, I am getting some pseudo rejections.
Okay.
That means the part may be okay, may not be
But
okay,
actually
but
it has got rejected. Yeah.
it's
Yeah.
getting rejected.
Yes.
So
Type 1, type 2 error.
type 1, type 2
Okay.
errors. So what our problem here is, we have to identify which process is creating this final as an outcome, whether this is a pseudo rejection, okay or not okay. So we have captured all the data from the entire process. Maybe 1,000 readings we have taken. Some 500 okay parts, 500 not okay, based on the
Yeah.
pseudo rejections. And this
Right.
data we are taking and then trying to come out with the parameter or the process which is the highest contributor for that particular rejection.
So right. Yes. This requires a much more rigorous business input, and it requires what is called explainable AI. How did you solve this problem, by the way?
Actually, we are still have not solved the problem, but at
Okay.
least what we have done is, with the inputs and our technical team, a lot of inputs we have given, and then we have come out with top 5
Possible reasons.
because of which this is happening.
Okay.
So we
Now,
are still trying.
Okay, if so, this is something really is interesting. So, will you be there in Bangalore on 12th?
12th, I am not available.
Oh, okay. 12th, yeah, I'll not meet you on 12th. I
Yes.
think most people are there. So anyway, that is because this is definitely something that is quite interesting, and there is a concept called explainable AI. Okay, explainable AI is something that should be used to solve this problem. Okay, so if you are interested later on, as a kind of a how this can be solved, since you are already working on it, we can probably discuss this offline. Okay.
Sure.
Because it's
I
a
will
very
connect.
interesting case of explainable AI.
Okay.
Because what you are saying is that there are certain type 1, type 2 errors that are happening, and you need to figure out why is this happening. Okay. You have to explain why the model is predicting the way it is predicting. Okay. So that's the whole idea of explainable AI. But right now, when the rejection is happening, or whichever, is it using a machine learning, or which is it using engineering, some engineering parameters?
Engineering parameters only. Today, whatever is.
So right now it is engineering parameters. So two things can be done. One is instead of engineering or physics-based system, if we use a database model, will it give better results? Or that's one, and the other is explaining that because because you're using an engineering based model, so somewhere the engineering formula is going wrong. Okay, so that's what you're trying to find out. Now,
Yes.
one way to see is that if I move to a database model rather than engineering based model, and of course if I have sufficient past data on that, then will it give me better results? Because the problem with engineering model is that there are maybe many parameters which probably has not been considered in the engineering model, or it has been considered wrongly. So we can talk about this later on offline. It's a very interesting use case.
Sure.
Okay.
I will connect with you.
Yeah, sure. Okay, great. So I think we have done this particular type of regression problem. We will now move into the next type of problem, which is called the classification problem. So let me just just give me a second. So classification problems are unlike regression, where we are saying that, okay, I have to predict what is the mean time between failure. Here I am saying that I have to predict whether a machine is going to fail or not fail. Okay, so this is the classification problem. So So I may have, in a very simplistic format, I may have, let's say, a temperature as only one variable, okay, machine temperature. And this was previously when it was mean time between failure, MTBF, it was something like this. The points were like this. And we're trying to draw a best fit line. Okay. So more the machine temperature, lower is the mean time between failure. Okay. But this time our problem is different. This time our problem is that I'm taking only one variable because otherwise it's difficult to draw. I mean, I cannot draw the diagram. Okay, so that's why I took only one variable. In case of regression, it is a simple linear regression. But in reality, we saw that we'll have multiple linear regression. Okay? Here also, in reality, we will have multiple factors that will govern this outcome. So here, let's say machine temperature. And instead of saying that what is mean time between failure, I'm actually having two scenarios, fail and not fail. The data that I've collected are some of them not fail. So it is only two values, fail and not fail. Some of them not fail. Some of them not fail and some of them fail. So in general, we can say that when the machine temperature is high, there's a high chance of the machine being failed. Machine will fail. On the other hand, if I when the machine temperature is generally generally low, the machine is unlikely to fail. Though there can be some exceptions. There are some exceptions, as we can see, that even when the machine temperature is low, the machine has failed. On the other hand, when the machine temperature is high, the machine has not failed. Okay. Now, our job is to predict. What are the different ways of prediction? So this also supervised the machine learning. Previously, this is also supervised machine learning because in the previous case also I had past data of both the outcome and the input. Here also I have the past data of the outcome. I have the past data about the machine temperature, and I have the past data about whether the machine is going to has failed in the past or not. Okay, both are supervised machine learning. However, in the first case, the outcome was a continuous value. In this case, the outcome is a categorical value, either fail or not fail. Now, how can I do this prediction? Now, one way is that just like I follow the same linear regression principle, and I say that, can I draw a line, a best fit line, so that the root mean square error is minimal? Now here I have a problem. The problem is that because the output data is not continuously, it's not a continuous distribution like here. It is a categorical distribution, two values. The best fit line will never really be a best fit. And most importantly, the best fit line can take any value. So I can predict this value. I can predict even a negative value, okay, which has no meaning because the output, the prediction has to be a fail or a not fail. Okay. So this kind of the classical regression model will not work here. So if this is the equation, y equal to mx plus c, y equal to mx plus c will not give me a very good result because the value of y will be a continuous value. Whereas we want something categorical like close to 1 and close to 0. Okay. How can I convert this line to a different shape of a line so that the output becomes more like a categorical output of 0 and 1? Can you think innovatively? What should I do to this blue line to get a new line that will give me two categorical values as far as possible? How should the line
Should
look
be
like?
polynomial.
Okay, so what type of polynomial? How will the line look like?
See, we did this in
Sinusoidal.
Yes, sorry.
Yeah, go ahead, Rajesh.
so we had this during, I think, quantitative methods. So where
Yes.
the shape will be like an S shape.
The shape would be like an S shape. The shape will be like an S shape. What is the advantage of doing an S shape? The advantage of doing an S shape is most of the cases, the line will fall either on the top side or on the fill side or on the not fill side, either towards 1 or towards 0. Most of the cases, except a small band here where it might lie in between 1 or 0. Except that, unlike the blue line, where the blue line I was not able to clearly say whether it's towards 1 or towards 0. The green line, in most of the cases, I'm able to say that it is towards 1 or towards 0. So what is this S-shaped line called? It's called a sigmoid function. So I need to apply a transformation on this y, on this equation. I need to transform this blue line into this green line. What is this transformation? So there should be a transformation z which is equal to function of y. And what that would be? 1 by 1 plus e to the power minus y. So if I can make a line z which is equal to 1 by 1 plus e to the power minus y, then I will get this sigmoid function. What is y? The y is the normal regression line. So we make the normal regression line. After we make the normal regression line, we make a transform to z, which is making this blue line look like a S line. Why we are doing that? Because we want the S line to predict either 1 or 0, not a continuous value. Clear? This is one of the methods of classifying the outcome into, let's say, two classes. Okay. This is called logistic regression. Why logistic regression? Because it is originally taken from regression. It is a transform of the regression. And remember that the logistic regression, the output is actually a probability. The output Z will be a probability. Probability between 0 to 1. output will be a probability, and we will put a cutoff value of 0.5. If the value is less than, output of Z is less than 0.5, it will belong to one class, and we have to define which class we are talking about before that. If I say less than 0.5, it will fall under not fail. Then greater than 0.5 will fall under fail. And the reason why we're having a sigmoid function, because our objective is that the number of cases where it will fall between, let's say, 0.3 to 0.7 should be very less. Most of the values either should lie towards 0 side or towards 1 side. If there are more values near 0.5, that means the accuracy of the model is not very high. Clear, everybody?
Yes.
Just like for regression, logistic regression also only works when all the input parameters are numeric values. It will not work on non-numeric values because, sorry?
It means that there is a small window where it could be somewhere between 0 and 1, which is fail and not fail.
Absolutely.
And for those cases which are falling in that window, what do we do? I mean, if the model now predicts, let's say, 97% accuracy.
Yeah, absolutely.
Sorry?
So there will be a cases of type 1, type 2 error. So
Yeah,
there will be
exactly.
cases where the machine will be classified as likely to fail when the machine is not likely to fail, and vice versa. Okay, so in case of regression, you have an error which is defined by R square. So lower the R square, higher is the error. So here you have an error which is defined in terms of misclassification. And that specific thing is called confusion matrix. It's similar to type 1, type 2 error in statistics. Okay. Here it is called confusion matrix. It's basically number of misclassifications. Number of cases where the model has identified that the machine will fail, but actually the machine is unlikely to fail, and the number of cases where the model has identified the machine will not fail, and actually the machine failed. Now,
And how do we
interestingly,
deal with such cases in reality? In real world, how
How
do
do?
we deal with such predictions? How do we deal with such predictions in
you
real
have to
world?
live with those errors.
And
So that's the whole idea
Okay.
of prediction. You cannot be 100% accurate. Now, the important thing is that you cannot, that's in statistics also, you cannot reduce type 1, type 2 error simultaneously. If you try to reduce one type of error, okay, automatically the other type of error will increase. That means if you want to reduce those cases where, let's say there are two cases. One case is where the machine is predicted to fail, but actually the machine doesn't fail. And the other case where the machine is predicted not to fail, but the machine actually fails. So you cannot reduce both. Moment you try to reduce one of the errors that the machine has predicted is predicted to fail, but actually did not fail, you want to reduce that, other error will go. So you have to balance that. Now, how do I know
so that
which one
means
is more
a
expensive?
human has to always, let's say, validate these results, or how is it?
No,
I
no,
mean, if
no,
the machine now
no, you
predicts
cannot
something.
validate. You cannot validate. Nah, you have to live with that error. You have to, you know that out of 100 cases which you have predicted that the machine is going to fail, 2 cases it will not fail. Any machine learning problem is not expected to be accurate. You cannot be accurate. That is again another difference between physics-based model. In physics-based model or engineering-based model, you are expected to be accurate. Here you are not expected to be accurate. You cannot be accurate. You will be wrong in 20% of the cases or 10% of the cases, and you live with that. You wrongly detect those cases. You wrongly detected that somebody is a cancer patient when actually the person is not a cancer patient. And so you have to figure out where the cost is more. Will it be more expensive if you detect the machine is going to fail when actually it doesn't fail? If that happens, what is the cost? The cost might be an extra maintenance that you are doing because you predicted the machine is going to fail. You did some preventive maintenance on it, which was not required, but the machine was actually not going to fail. So the cost you are incurring is the maintenance that you are incurring on the machine. On the other hand, if you have predicted that the machine is not going to fail and actually the machine failed, that means the cost is, let's say, loss of production. Now you have to figure out which cost is more.
Yep.
Okay, that is what you can fine tune the model and arrive at a point where the cost is minimal. Okay, but it can never be that it will be zero. There will always be misclassifications. Okay.
Even with, I mean, it's always said that this artificial intelligence models learn with more data and more experience, and they get better and better. Now,
Yes.
even with whatever data and experience they get better, there is never a possibility to be 100% sure
No.
of what they are predicting, right?
No, because it's database model. It is not a physics-based model. There is no formula that will back. So there is a very, very, very remote possibility that will be 100% accurate.
Okay,
So
understood.
depending on
And that explains why there is always two pilots in the aircraft, no? In spite of having all autopilots or whatever.
Yeah. So wherever there is a critical event, where the cost of failure is very high, where you have to have a manual intervention, definitely a manual guardrail. Even the human can make a mistake, but what is the difference between human making a mistake versus a machine making a mistake? Human making a mistake is accountability. You can hold a human accountable. You cannot hold a machine accountable.
Machine accountable. Exactly.
Especially when you are using things like deep learning, generative AI, etc., where the way the model is created is like a black box. Explainability is low. That's why explainable AI is becoming one of the big things, because it is not sufficient in many cases to predict. You also have to explain, like I think you are talking about the use case, okay, where you have to explain why you are, I think Rajesh was talking about it, that why why something is failed or something is misclassified. For example, let's say in loan applications. So a lot of machine learning models are being used to accept or reject loan application, especially the fintech companies who are approving loans based on certain criteria where there is no human involved. On the spot loans, micro loans. Okay, I want to I want to take a small loan for this month, maybe for going out to have dinner or something like that. Okay, younger people are doing that a lot. Okay, so, or let's say education. Okay, so those kind of cases, there are a lot of fintech apps which are providing instant loans, and they work on these machine learning models which are going to approve or reject a loan. But there the question comes is that is it explainable? If somebody comes and asks you that why was my loan application rejected? Okay, can you tell me why it was rejected? I have kind of satisfied all the criteria. Your model should be able to explain why the loan application was rejected. Okay, so those kind of things are coming up. Explainability of the model. So wherever there is accountability involved, explainability of the model becomes important. Okay. So yes, those things are definitely there. So so I think we will close here today, because we will start this new classification from next class onwards, where we will see how we can build a classification model using first again KNIME and then Python. Okay. So today is Sunday, so I don't want to hold you back for long. Okay, and we will come back to the regular. And in between, hopefully, I'm going to meet some of you on 12th. Great. So who among this group, whom are we going to meet on 12th? You can just put up your hands. Rajesh said he is not coming. Otherwise, apart from that, others, Prashant is coming. Okay. Mohan, Vijay, Nagesh, great. Amit, Dinesh. Saurabh, what about you? Not coming?
No, sir. I'm in Nasik, so I won't be.
Oh, okay. Okay, it'll be online only. Okay, okay. Okay, fine. So good. Well, good to see some of you. Okay. Next week we'll continue. Okay. Bye. Bye, everybody. Bye.
Okay, thank you.
Bye. Bye.
Bye. Bye.
Thank you. Bye.
Bye. Bye.
Bye.